Hello, welcome. Today I'll be looking at integration. Now, I guess you should already know differentiation if you're asking me to teach you integration. So in differentiation, if you had y equals 2x to the power of 3, and you're told to differentiate y with respect to x, what this means is in differentiation, you multiply this 2 by 3, such that you now have 2 times 3 x to the power of, subtract 1 from the power. So x to the power of 3 minus 1. That will be 6x to the power of 2. This is for differentiation. For integration, it's the reverse. So where you do multiplication in differentiation, you do division. Where you do subtraction in differentiation, you do addition. So it's the reverse. So if we add y equals 2x to the power of 3, in integration, it will be, okay, here it's called the y dx. Alright, so also for differentiation, for integration, sorry, when you're integrating y, we don't call it the y dx, we use this symbol, integrand sign. So the integral of y equals the integral of 2x to the power of 3. Right? I'm going to explain in with more examples, but just looking at this, if this becomes 2x to the power of 3 plus 1, we add 1 to the power, and also divide by that same thing you just did, 3 plus 1. Right? So this becomes 2x to the power of 4 divided by 4. We divide this by 2 to get 1, divide this by 2 to get 2. And this is x to the power of 4 divided by 2. So this is integration. Right? Let me look at some examples of integration. There are many sides to it, and there are many ways we can solve the different problems. So generally, there are some basic integrals you should know if we are looking at the integrand of cos x dx. It's the same thing as sine x plus k. Whenever we integrate, we always add a constant. So in my previous example, I could add k as a constant. You could see some people using c, people could use k, any of them works. It's a constant. So these are definite integrals. These are already stated facts that when you integrate the constant of a variable x, it's going to give you sine x plus k. If you integrate if you integrate sine x dx, is going to give you negative cos x plus k. Alright, so I'm just going to keep this here. This is not all. If you integrate 1 over x dx, is going to give you what we call ln x or ln x. So it's the same thing as log x, right? We call it ln x. These are definite integrals that you should know because it will help you to integrate. Also, when you integrate exponential x dx, it still gives you exponential x plus k. Please remember, anytime I don't add my k, just know that there is a constant k. I do normally forget sometimes. Alright, so let's look at this example. Integrate x squared plus 3x minus 5x or minus 5. Whenever we integrate, we always put the x in case the variable is x. So how do we integrate this? First of all, we take it step by step. We said in integration, add 1 to the power, also divide by that power you just added 1 to, right? So we have x to the power of 2, we add 1, 2 plus 1. We also divide by that 2 plus 1 plus 3x. Now, what's the power of x here? Any variable where the power is not visible, the power is 1. So this is 1 plus 1 divided by 1 plus 1 minus 5. Whenever you are integrating and you have a constant, you are going to attach x to it or attach the variable that you are integrating to it, right? So we don't have any power here. So now we have x to the power of 3 divided by 3 plus 3x to the power of 2 divided by 2 minus 5x. Attach your k. This is your final answer. I'm going to give you more examples. So in the last video, I did some examples on introduction to integration. I'm going to do a lot of examples. I don't know how many videos it will take. The limit I have per video is 5 minutes. So this question says integrate 1 minus x divided by x to the power of 2. So to integrate this with respect to x. So in integrating this, we're going to follow this step. Why not break 1 minus x divided by x squared? Since they have the same denominator, we could write it as 1 divided by x squared minus x divided by x squared. So that we can now integrate both of them separately, right? Now, before we proceed, you see that x is common both in this numerator and denominator, which means we can write this as 1 divided by x squared minus, if we divide both sides here by x, we'll be having 1. And if we divide this by x, we'll be having x, 1 divided by x. So, it means that what we are integrating, 1 minus x divided by x squared dx, remember, has now turned to 1 divided by x squared minus 1 divided by x dx. Good. Now we can rewrite this as taking them separately, integral of 1 divided by x squared dx minus integral of 1 divided by x dx. Alright, that's integration. You can take them separately. Okay, so based on the laws of indices, 1 divided by x squared can be written as x to the power of negative 2 dx. Remember, in indices, when you are dividing, let's say you are dividing 1 by a variable that has a power, you can rewrite it without this. You can write it as if this is not a denominator, but you have to make the power negative, right? Now minus, remember also, we said that based on the what did we say now? We said based on the integration or general integration, that 1 divided by x, if you're integrating that, is also ln x, right? So this will be ln x. I mean, this part will be ln x plus k. All right. Now we have to integrate this part. How do we do integral? We said add 1 to the power. So this is x to the power of negative 2 plus 1. Divide by that same negative 2 plus 1 minus ln x plus k, right? So this is x to the power of negative 1 divided by negative 1 plus, minus ln x plus k. Good. Now, what this means is that we have negative x to the power of negative 1 negative x to the power of negative 1, just going to clean this, minus ln x plus k. Also, based on our knowledge of indices, when we have a power of a variable that is negative, we can rewrite this as a denominator so that the variable has a positive power. So this is minus 1 over x minus ln x plus k. Right? So this x to the power of 1, which we don't need to write. So this is the final answer. Let me see if I can complete another video within the time I have. Okay. So we have this question, integral of 1 over x plus cos x. I told to integrate this with respect to x. Okay, so we can just separate it, 1 over x dx plus cos x dx, right? And we said the definite integral of 1 over x is ln x. Good. Yeah, integral of cos x, if we go up, we said that is sine x, right? So sine x plus k. This is your final answer for this question. Alright, so I want to look at this question. It says integrate. Sometimes they write it as words. I'm just trying to make it fast now. Writing it this way: integrated squared plus 3x plus 2 divided by x plus 1 dx. Now, this will be a little bit difficult for us if we just go directly and try to integrate them one after the other. So what we'll do is we'll try to see if we can factorize x squared plus 3x plus 2, and if one of the factors is the same as the denominators. If that is the case, then we can divide, right? So x squared plus 3x plus 2, remember factorization, this could be x squared plus 2x plus x plus 2. I hope you remember this. This is x is common, x plus 2, plus 1 is common, x plus 2. Good. So we have x plus 2 common. We can pick one of them, x plus 2, and then we have x plus 1. This is our new numerator. So we have x squared plus 3x plus 2 divided by x plus 1 dx. This could be written as our new numerator, x plus 2 multiplied x plus 1 divided by x plus 1. Good. So you see x plus 1 is common, we can cancel out. Don't forget the x. So we can rewrite this as x plus 2 dx. Now it's easy. If we integrate this, remember integration, you add 1 to the power, so x to the power of 1 plus 1 divided by that 1 plus 1. And for constant, 2 is a constant, it doesn't have any variable x, right? So for constant, you attach the variable. The variable we have is x, so you attach x to it, 2x. You don't add any power because you are just attaching it. So plus k, which is x squared divided by 2 plus 2x plus k. So this is your final answer for this question. Let me look at a different question. Okay, so if we're told to let me see, there's a definite integral that I might have skipped. Okay, I don't have it handy here. We're told to solve or integrate tan squared x dx. This is not so easy. What we could do is we can rewrite tan squared x as tan squared x is the same thing as sec squared x minus 1, right? Dx. The same thing as sec squared x minus 1 dx. The reason why we changed it to this format is because it's easier to integrate sec squared x than to integrate tan squared x, because sec squared x is a definite integral. So this is integral of sec squared x minus integral of 1 dx. Sorry, there's dx here, minus integral of 1. Just going to cancel this, please. Integral of sec squared x dx minus integral of 1 dx. Now, the integral of sec squared x is tan x. So that's why it's also a definite integral. Maybe I should have added it. The integral of sec squared x dx is tan x. So we can write this as tan x minus the integral of 1. 1 is a constant, remember. We attach the variable to it. So this would have been 1x. But remember, we do not need the 1 anymore. So it should just be x plus the constant k. So our answer is tan x minus x plus k. Alright, so I'm going to stop the video here and do another video also. So let's say we are given this question. So this is a little bit easy. Let's say we are given x plus cos x dx, right? And we are told to integrate. The easy way is to take them individually, x dx plus cos x dx. If we integrate x, we add 1 to the power, so x to the power of 1 plus 1 divided by 1 plus 1, right? If we integrate cos x, we said it's going to give us sin x. Let's check again. Definite integrals. Yeah, cos x is sin x plus k. So we integrate this is going to give us sine x plus constant k. So this is x to the power of 2 divided by 2 plus sine x plus k. Good. Now this is the answer. Let's look at a different type of question. So if we are given cos 2 theta, I'm not using x now, cos 2 theta the theta, how do we solve that? Now theta is a variable, whether it's x, whether it's anything, that's just a variable. This is not as easy to solve if you want to go through the steps, but okay, let me solve it first, then I'll tell you the shortcut to knowing the answer if it's an objective question. If it's a theory question, this is what you do. Change the variable here. Change 2 theta to a variable. So we can assign it the variable u. We say u equals 2 theta. Right? U equals 2 theta, and then we say du the theta, because we are differentiating u with respect to theta. Right? So this is where you use differentiation also. Differentiate u with respect to theta, it's du the theta would be 2. Right? Now, what do we do? Du the theta is 2. So this means that du, or more like we want to replace the theta now, we'll be substituting the theta. So first of all, let's multiply both sides by the theta. As du will be 2 the theta, and then we'll make the theta the subject formula. The theta will be du over 2. Good. So now we can go back to our question, which says cos 2 theta the theta. We'll substitute 2 theta with u. Remember, u is now 2 theta, so this is cos u. Now we have changed 2 theta to u. What happens to the theta? We said that the theta is the same thing as du divided by 2. So multiplying by du divided by 2. Alright? So this is a fraction. Du divided by 2 is the same thing as du multiplied 1 over 2. Okay? So let me just write it that way. So this is cos u times du times 1 over 2. And when you are integrating, you have a number multiplying what you are integrating. You can take the number outside, right? So this could also be written as, before we take it outside, we can write it as 1 over 2 cos u du, which we can take 1 over 2 outside the integral sign. 1 over 2 cos u du. So this is now easy for us to solve. We can integrate cos u. We'll have 1 over 2 sine u plus k. What is u? We have to get back to changing the value of u, because that's not in our original question. What is u? From our substitution, we say u is 2 theta. So this is 1 over 2 sine 2 theta plus k. Alright? So that is the final answer. That's how we solve this kind of question. Alright, so just to emphasize what I did, I'm going to do a different one now. Just to emphasize what I did in the third video. So if we had sine 3x dx, it's a similar question. What we do, let me explain in a new way. What we do is we will assign 3x to a different variable. We want to make it easy for us. This 3x is confusing. So let me make it easy for us. So let's say let u be equals 3x. I like using u. What we do next is we differentiate u with respect to x. So that becomes du with respect to x, which is dx. And differentiation is the same thing as 3x to the power of 1 minus 1, or 3 times the power 1, x to the power of 1 minus 1, right, which is 3x to the power of 0. And based on the laws of indices, anything to the power 0 is 1. So this is 3 times 1, which is 3, right? So du dx is 3. Good. Now we've gotten du dx to be 3. That is good, but where do we use that? We want to, since we've already substituted u to be 3x to be u, we need to also change the dx to be in terms of u. So this is why we are differentiating this. So du dx we said is equals to 3. We need to make dx in itself a subject formula. So we'll go through the step of multiplying both sides by dx, right? And this cancels out. So du is 3 dx. And then we divide both sides by 3 just to make dx a subject formula. So this will be dx, this is cancelling out, dx will be du divided by 3. So if we come back to our question, sine 3x dx, we now replace 3x and dx with sine 3x is, remember, 3x is now u, so sine u multiplying dx, which is now du divided by 3, right? And I said du divided by 3 is the same thing as du times 1 over 3. So this is sine u times du times 1 over 3. Okay, so we can take the 1 over 3 before the sign because it's just a number, and that becomes 1 over 3 multiplying sine u and that times du. So now what we can do is to take the number outside the integrand sign. So this is 1 over 3 multiplying, okay, integrand of sine u du. Now integral of sine u is negative cos u, right? Yeah, negative cos x plus x. So this is negative cos u. So this is 1 over 3 multiplying negative cos u plus k constant. So that is negative 1 over 3 cos u plus k. What is u? Remember, u is 3x. You can't leave your answer with u because that's not the original question. So you get back to how they gave you the question, which is in terms of x. So this is negative 1 over 3 cos, instead of u, I'll have to put that 3x plus k. Right? That's the answer. Now the shortcut. This is the shortcut. Okay. If we have the integral of sine k, let me use a number, sine 4x dx. Just take the 4 and make it a denominator, right? To get your final answer. Make it a denominator, 1 over 4. Integrate sine x is negative cos, right? So put negative cos 4x plus k. That's the simple way. If it was cos 4x, for instance, dx, make 4 the denominator and we have 1 over 4. Integrate cos x, it's sine, right? Sine 4x, remember your 4x, plus k. Alright, this is when you have an OBJ question. If it's theory, please stick to the solving of the question so that you get it. Right. Goodbye. Alright, so we want to look at the question where we are not looking at three questions of cos or sine. We're also going to substitute. So if we have the integral of 2 multiplying 2 minus 2x minus 3 power 2 divided by 3 dx, how do we integrate this? Remember I told you if you have a constant multiplying anything inside the integrand sign, if it's a constant, if it's a fraction, at first it's a constant, you can take the 2 in this case outside the integrand sign so that we first of all know how to make it easy. So this is 2 multiplied the integral of 2x minus 3 power 2 divided by 3 dx. How do we solve this? Do we just do 2x minus 3 to the power 2x 2 divided by 3 plus 1, 2 divided by 3 plus 1? Nope, this won't work. If it was just to the power of 2, we could multiply it by itself and then find a way around it. But this is a little bit difficult. So what we do is we say so they are like using u, so let u be 2x minus 3, right? If u is 2x minus 3, I want to substitute this with u, then I also need to change dx to be in terms of u. So that's where I'll first of all integrate du by dx, du divided by dx. This is 2x to the power of 1 minus 1 divided by 1 minus 1. Remember integration, 2 times 1 divided, okay, minus 3 is a constant which is 0 if we integrate it. So this is 2x to the power of 0. Oh, I'm sorry. This is not divided by 1 minus 1. That's wrong. Du dx is 2 times 1, x to the power of 1 minus 1, minus constant 0. Alright, so this is 2 x to the power of 0, which is 2 times 1, which is 2. Right, so I'm just following the long process. Just know when you're integrating, for instance, 2x minus 3, your variable is x. The highest power is 1. Just take the number that is attached to it. So that's your integration. Good. Now, if you go back, we have du dx to be equal to 2. I told you, since we have already replaced 2x minus 3 here with u, we need to make dx to be in terms of u. That is where we do change of subject formula. We make dx the subject formula, right? So we can first of all multiply both sides by dx, du will be equals to 2dx, and if we divide both sides by 2, dx will be equals to du divided by 2. And so if we come back to our question, which was 2 multiplying 2x minus 3 to the power of 2 over 3 dx, it is now 2 multiplying 2x minus 3 is now u, remember, but we still have our power 2 over 3. Dx is now du over 2. Remember, I told you du over 2, du times 1 over 2, right? Okay, so this is 2 multiplying u to the power of 2 over 3. To make it easy for me, I can say du times 1 over 2. So this 1 over 2, I'm going to take it outside immediately. So this is 2 times 1 over 2, u to the power of 2 over 3 du. 2 will cancel 2, so I just have 1, which is not necessary anymore. So now I have u to the power of 2 over 3 du. So integrating this is where I now add the power. I add to the power 1 as 2 over 3 plus 1 divided by 2 over 3 plus 1 plus k constant. And if you add that in the power, that's u to the power of, I think that's 5 over 3 divided by 5 over 3 plus k. Good. So this will be u to the power of 5 over 3 divided by 5 over 3 plus k, which is u to the power of 5 over 3 times, you do the multiplicative inverse. That means you multiply, instead of divide, you multiply, but you change it to 3 over 5, the inverse, plus k. Right? So this is u to the power of 3u to the power of 5 over 3 divided by 5 plus k. Remember to substitute back your u. What's u? U is 2x minus 3. So this is 2x minus 3 to the power of 5 over 3 over 5 plus k. That's your answer. Alright, so I think this will be my last video. I would have established a foundation already, so you can do more practice questions after this. So there are cases where we are given a range, so integral from 1 to 3, for instance, of x squared minus 1. This is very easy, right? What you do is you do your normal integration and then you put in the values. So let's do. Normally when we integrate, we say, can I go direct? Okay, let's do it one after the other. Say x squared dx or 1 dx. I hope this is not confusing, or should I go directly? So this is the same thing as x to the power of 3, that is 2 plus 1 divided by 2 plus 1 minus, we said if you have a constant, you give it the variable. So x, there's no power here, the power is 1 in fact. Alright, so now what we do is, do I need my k? I don't need k here. What I'll do is, I'll put this straight line at the side of these two of them. I'll put the straight line and I'll put my range, which is 1 to 3. Okay, so now this becomes x to the power of 2 plus 1, 3 divided by 3 minus x, 1 to 3. When do I use this range? Well, this is how you do it. First of all, you work with 3. We put in 3 in terms of x, that's 3 to the power of 3 divided by 3. Put in 3 also for this, minus 3. Put that in a bracket. That is for the upper, I think they call it upper limit or something. Alright, minus the lower one, which is 1. Whenever I see x, I'll put 1. So that's 1 to the power of 3 divided by 3 minus 1. Okay? Now, 3 to the power of 3 is 27. 27 divided by 3 minus 3 minus 1 to the power of 3 is still 1 divided by 3 minus 1. So let's move here. 27 divided by 3 is 9. 9 minus 3 minus 1 over 3 minus 1. So this is 6 minus 1 over 3 minus 1. Okay, let's make 3 the denominator, the LCM. 3 times 6 is 18 minus 1 minus 3, which is 17, which is 14 divided by 3. Is that correct? Yeah, 14 divided by 3. Or 4 whole number, 2 over 3. Is that also correct? Yeah. So this is let's our final answer. Are we correct? I think we are. Let me check. Let me check. Oh, we're wrong. So I made a mistake from this part down. So let's check it again. Let's work on them separately before we bring them together. So 9 minus 3 is 6, right? 6 minus, let's work on this bracket. 1 over 3 minus 1, denominator is 3. That will be 1 minus 3, which is 6 minus, that's negative 2 over 3. Okay? So that's 6 minus is plus, 6 plus 2 over 3, which is actually denominator 3, 18 plus 2. So that's 20 over 3, which is 6 whole number, 2 over 3. Is the final answer, right? I think that will help. This is the last video I'm going to do. That will help. This will help give a foundation to integration. Integration is very easy, but same thing like other topics in maths, you have to do a lot of practice. Last time I did integration, I don't remember, but you see I can do it again because I've done it a lot of times in the past. So you have to do a lot of practice. It will help you. Integration is very, very easy.